Now that we've solved a system by transforming it into echelon form, let's look at reduced row echelon. Echelon form had ones along the diagonal and zeros below. Reduced row echelon form has ones along the diagonal, zeros above and below. All right, let's try solving this system. So I'm first going to put this into a matrix. 4, 2, -3, 6, 1, -4, 1, -4, and then -1. There are no y's, so I've got to put a 0 there. 2z, and then 2. Now, again, I've got a 1 here, so the easiest way to get a 1 where I want it up here is to flip row 1 and row 2. So I'd have 1, -4, 1, -4. Now, the second one is going to be 4, 2, -3, 6, and then -1, 0, 2, 2. Now, to get a 0 here, I'm going to do -4 times row 1, add it to row 2, and put it back where row 2 is. So I'd have row 1 stay the same, 1, -4, 1, -4. But I'm doing -4 times this. So -4 added to 4 is a 0. -4 times -4 is positive 16, added to 2 is 18. -4 added to -3 is -7. Positive 16 added to 6 is 22. Now notice I can also get a 0 here by adding row 1 and row 3 and putting it back where row 3 is. So 1 added to -1 is a 0. -4 added to 0 is a -4. And then 1 added to 2 is a 3. And then -4 added to 2 is a -2. Okay, now I want a 1 here. I don't want to divide by 18, so I'm again going to flop row 2 and row 3. Now notice, if I divide row 3 by a -4, I'll get a 1 there. All right, let's do that all at once. So row 1 stays the same, 1, -4, 1, -4. And row 3, I'm going to put where row 2 is, and I'm dividing by -4. So 0 divided by -4 is 0. -4 divided by -4 is 1. 3 divided by -4 is -3/4. And then -2 divided by -4 is a positive 1/2. And then row 2 stays the same, but it goes here. Now. All right, now I'm going to add -18 times row 2 to row 3 and put it back where row 3 is, so that I get a 0 here. So let's keep the middle the same, 0, 1, -3/4, 1/2. So I'm going to go 0 added to 0 is 0. -18 added to 18 is a 0. -18 here will make that a positive 27 halves. Positive 27 halves added to -14 halves is a 13 halves. And then -18 here will make that a -9. Added to 22 is a positive 13. Okay, now I'm not just supposed to get zeros below, I'm also supposed to get a 0 above. So if I do 4 times row 2 added to row 1 and put it back where row 1 is, then 0 added to 1 would be 1. 4 added to -4 would be a 0. If I multiply this by 4, I get a -3. Added to 1 is a -2. And then 4 times a half is 2. Added to -4 is a -2. Now, I always use the 1 to get zeros in the other places. Never try and use another number. All right, now I need a 1 here. So I'm going to do row 3 multiplied by 2 over 13 to get a 1 there and put it back where row 3 is. So I will have row 1 stays the same, 1, 0, -2, -2. And then row 2 will stay the same, 0, 1, -3/4, 1/2. And then row 3 will be 0, 0. Now I'm multiplying by 2 over 13, so that becomes a 1. and 2 over 13 here will become a 2. Now I'm going to use this 1 to get a 0 here and here. So I'm going to do row 3 times positive 2, add it to row 1, and put it back where row 1 is. All right, so 0 added to 1 is a 1. 0 added to 0 is a 0. 2 added to negative 2 is a 0. 4 added to negative 2 is a 2. All right, now notice that I also need a 0 here. So I'm going to multiply row 3 times 3/4. And add it to row 2 and put it back where row 2 is. So 0 added to 0 is 0. 0 added to 1 is 1. 3/4 added to negative 3/4 is 0. 3/4 times 2 would be 3/2. Added to 1/2 would make 4/2, which is 2. And then row 3 stays the same. 0, 0, 1, 2. Notice now I read this as 1x plus 0y plus 0z. So x equals 2, y equals 2, z equals 2, and my solution to the system is the ordered triple 2, 2, 2. Let's check it. 8 plus 4 is 12, minus 6 is 6. 2 minus 8 is negative 6, plus 2 is negative 4. Negative 2 plus 4 is 2. Our solution works. All right, now you can also do this on your calculator using the reduce row echelon form key. So I'll show you where that is really quickly. So in my calculator, I'm going to go second and matrix, and I'm going to edit A. A needs to be a 3 by 4. My coefficients are 4, 2, negative 3, 6, then 1, negative 4, 1, negative 4, then negative 1, 0, 2, 2. Once I have that entered, go back to our home screen, go back into the matrix, over to the math key, and we want to arrow to where we find the reduced row echelon form, which on my calculator is option B here. And so I want to go reduced row echelon form, second matrix, pick up the name A, enter, and we see we end up with the reduced row echelon form, which is unique. It's a solution to our system. All right, so let's show that the following system is inconsistent. So if I look at this, the first thing that I'm going to do is put that into a matrix. So the augmented matrix would be 1, 2, 1, 4, 1, negative 2, 3, 1, 2, 4, 2, 9. Then I am going to do, to get a 0 here, I'm going to do negative 2 times row 1 and add it to row 3. So if I do negative 2 added to 2, that'll make a 0 here. Negative 4 added to 4 is a 0 here. Negative 2 added to 2 is a 0 here. Negative 8 added to 9 is a 1 there. 0, 0. So 0x plus 0y plus 0z equals 1. I get 0 equals 1. That's an untrue statement. So that tells me anytime I end up with something like this, it's going to be no solution. If you get it in your calculator, it'll look like this. Again, that's a no solution. All right, let's show that this system is dependent. Okay, so my augmented matrix here is 2, negative 5, 3, 1, 1, 4, negative 2, 8, 4, negative 10, 6, 2. So to get a 0 here, or to get a 1 up here, I'm going to, nope, they didn't. Okay, so to get a 0 here, I'm going to multiply negative 2 times the first row and add it here. So negative 2 times 2 is negative 4 added to 4 is 0. Positive 10 added to negative 10 is 0. Negative 6 added to positive 6 is 0. Negative 2 added to positive 2 is a 0. We end up with all zeros. Notice this is different. This would be 0x plus 0y plus 0z, so 0 equals 0. That's a true statement. When a true statement happens, we have infinitely many solutions. So to find it, I'm going to take the other two and solve it in terms of one of the variables, right? So the top row represents this equation. The bottom row represents that equation, the middle row. So for this matrix, I can get this into row echelon form by swapping row 1 and row 2. So row 1 will come up, row 2 comes down, looks like that. And then I can do negative 2 added to 2 gives me a 0 here. Negative 8 and negative 5 gives me a negative 13 here. Positive 4 and 3 is 7. Negative 16 added to 1 is negative 15. All right, now I just need a 1 here. So I'm going to divide that by negative 13. So 0 divided by 13 is 0. Negative 13 divided by negative 13. 7 divided by negative 13. Negative 15 divided by negative 13 is a positive 15 over 13. Now I can back substitute. I've got the 0, 1, negative. So this is saying y minus 7 over 13z equals 15 over 13. So I can solve for y here by adding the 13 over 17 to the other side. And I would have 15 over 13 plus 7 over 13z. Now back substitute into this previous equation here, this new value of y. And I would get x plus 4 times that y minus 2z equals 8. Distribute the 4. 4 times 15, 4 times 7. Gather these like terms. So I'd have 26 over 13 plus 28 over 13. So that would be 2 over 13z. And move it to the other side. So I'd have minus 2 over 13 when I move it to the other side, and I'm subtracting 60 over 13. So I'm doing 8 over 1 minus 60 over 13. And 8 times 13 is 104. So that gives me the 44 over 13, and then minus the 2 over 13, and that's my x. Now I can write that as an ordered triple. So my solution is x has to be this value, so 44 minus 2z over 13. Y has to be this value, so 15 plus z, 7z over 13. And then z can be anything. So there are my infinitely many solutions.